Hi, seventh graders. I hope you're doing well. Today, we are going to take that data from your coin flip, and we're going to be comparing theoretical probability and experimental probability. We all know that the probability of flipping heads is 0.5 or 1/2, 50%, and the same for tails. But is that what actually happens when we flip a coin? Is it truly 50-50 probability? So we're going to take the data that you collected and we're going to see how they compare. First of all, I randomly selected a student's set of data, and I'm going to be using the tools in Sheets to calculate the experimental probability and also the percent error. If you didn't know that or know this already, Sheets is like a huge calculator. You can do anything in it that you would do on a normal calculator. And the nice thing is if I were to change these numbers, I wouldn't have to type it into a calculator again. It would automatically update. Okay, so let's take a look at the experimental probability for flipping heads. I already have theoretical probability filled in. We already know that the probability is 0.5 for heads, 0.5 for tails. Experimental. Well, we're going to put an equal sign here. We flipped heads 32 times out of 50. So that means the experimental probability is going to be, actually I'm going to put the cell number in, that's A2. What it's going to do is it's going to take the number that's in A2, 32, and then we're going to divide it by 50 because that's the number of times you flipped that coin. And there we go. So the experimental probability, just based on that student's data of flipping heads, is 64 hundredths. Okay, now let's do the same thing for tails. We have 18, well actually I'm not going to use 18, I'm going to use the cell number, B.B2, divided by the number of coin flips, which was 50. And you can see that the probability, experimental probability, is 36 hundredths. Now, before I go on to percent error, I just want to show you this cool feature in Sheets. Let's say that I want to use a different student's data. Let's say that that student had 28 heads and 22 tails. You can see that the probability, the experimental probability, has updated without having to change those calculations. Okay, so let's go ahead and go back to our original numbers here. Now, percent error. You should count your lucky stars that we are doing distance learning right now because we are not going to expect you to learn how to find percent error. So I'm just going to be putting the formula in for percent error, and I will be explaining what the results mean, but you will not actually be required to calculate it. So percent error is the experimental probability, which is in this cell E4, so E4. Actually, I'm going to put some parentheses around this. We're going to subtract the theoretical probability, which is in cell E3. We're going to divide by the theoretical probability, E3. And then we're going to multiply by 100 so that we get 8%. Okay, that's pretty high. So the percent error is 28%. Now I'm going to copy this and I'm going to move it over here. Okay, so notice that the equation that I used to calculate percent error, when I moved it over here and copied it, it automatically updated so that it was cell F3 and cell F4 that we were using. And then this is the percent error. Percent error is going to be the same for both of these. Sometimes you'll see a negative, but we won't go into that right now. But we can say the percent error for this experiment was 28%. Now, what I want to do is I want to take a look at one class's data. We're going to find the experimental probability for the entire class. And we're going to see if it's any better than this 28% probability. Because if this was true and the percent error was 28%, I would say that the coin probably is not balanced, and the probability, theoretical probability, probably shouldn't be 0.5. Okay, but let's take a look at what happens when we do a class. Now, before we get started, I want to go through, some students did not follow the instructions carefully. They're supposed to flip a coin 50 times. If you add 29 and 34, that does not add 50. So any data that doesn't follow the rules, basically, I'm going to delete, okay? Here's another example of some data that didn't follow the rules. It looks like they only flipped the coin 20 times. That's not going to work for us. We wanted every student to flip it 50 times. So I'm going to delete this set of data too. All right, now that I have those sets of data deleted, everything looks good from here on out. I'm going to first find the average or the mean of this data. So first I'm going to do the heads outcome. So let me put my equation in here. We do equals, and now sum means that you're going to add up everything. So I'm going to add up everything from the cell A2, because that's where the data starts, to A29. Okay? Now remember, when we find mean, we add them all up and we divide by how many there are. So I'm going to divide by 28 because there are 28 sets of data. Wow, look at that. So the average for this class is 24, and I'm going to round it to like 24.5. That is pretty close to 25. Let's take a look at the tails now. I don't need to do anything fancy. I'm just going to copy that same formula over for tails. And you can see that it is just a little bit above 25. So this is very close to what it would be like if it was a 50-50% probability. Well, it is, but you can see that the experimental is pretty close to being 25-25. Let's actually find that probability. We're going to take the mean here and we're going to divide it by 50 because that's how many times the coin was flipped for each student. So I'm going to take that cell number, E25, and I'm going to divide it by 50. What this means is the experimental probability is roughly 49 hundredths, okay, or very, very close to 0.5. So you can see that that probability is pretty close. Now I'm going to take that formula, I'm going to copy it over here. And so for tails, it's about 51 hundredths, okay, very close. So let's go ahead and find the percent error now. And remember, the smaller the percent error, the more accurate the closer the experimental probability is to the theoretical probability. Okay, so let's say here we are going to do the experimental, and that's in E27. I do need parentheses around this. Minus the theoretical, which is E26. And then we divide by the theoretical, which again is E26. And then we multiply by 100 to get that percent. All right, so it's about 2%. The percent error is about 2%. That is super, super low. So let's copy it over to the tails section, okay? Remember, don't worry about those negatives. Right now, we're not going to worry about that. So if you look back at the student data from the first go around, the percent error was 28%. That is huge. But the more students that flipped coins, the closer we got to the actual theoretical probability. The percent error now is very small. It's about 2%. So let's see what happens. This was only one class set of data. Let's take a look at all the classes together. Okay, again, just like in the last sheet, we have some students that didn't quite follow directions, and so we're not going to consider their data valid. So I'm going to go through and delete it. They flipped heads once and tails once, so we're going to go ahead and delete that. Also in this set of data, you're going to see that some people accidentally submitted their data twice. So I'm going to delete one set of their data. So here this adds up to 60, so I'm going to delete this. 10 and 10, it does not add to 50. Okay, let's see what else. 50, 50, nope, that's 100 flips. Another set of 100 flips. Okay. Okay, another set of 100 flips. Now the student accidentally entered their information twice, so I'm going to delete one set of it. This student flipped a coin 20 times. We'll delete that. 60, what is that? 63 times? Okay, let's see here, 70 times. That's not going to do it. These two different students that enter their data twice. So I'm going to delete a set of data for each of those students. Okay, this student, 100 flips. Okay, again, this is actually two students that happen to get 25 and 25, but they each entered their data twice. So I'm going to delete. There we go. This student entered their data twice. The student flipped a coin 11 times. And this student did 100 flips. Okay, so now that we have cleaned up this data, we've eliminated all the data that didn't meet our criteria, we're going to come back and do the same thing we did for the class set of data. First of all, we're going to find the average or the mean. So I'm going to go ahead and type in my equation for that. So we're going to go from A2 to A194. Now that first cell, we didn't use A1 because that actually said heads. That's not a set of data, which means that we don't have 194 sets of data. We have 193 sets of data. So I'm going to divide by that. Okay, that's looking pretty good. That's very close to 25. And there's the set of data for tails. Okay, so you can see that you know, if it was a true theoretical probability, then there should be 25 head flips and 25 tail flips, and we are very close to that. Let's go ahead and calculate the experimental probability. We're going to take the number, the average head flips, which is 25.45 and so on, and we're going to divide by the 50 flips that were made. So this is going to be E191 divided by 50 flips. All right, and then I can just copy this and paste it here, and it's going to automatically change those cells for me. So you can see that the experimental probability for all the classes, all the 7th grade classes, is close to 51/100, and the theoretical is 50/100. So we are pretty close here. Let's go ahead and take a look at the percent error. I'm not sure we're going to be able to beat that class set of data that had a percent of error of 2. Let's take a look at that again. Yeah, it was about 2% error. So let's see what this one is. We're going to do the experimental probability, which is E193. We're going to subtract the theoretical probability, which is E192. We're going to divide by the theoretical probability, which is E192. And then we're going to multiply by 100 to turn it into a percent. Oh, we did beat it. Look at that. All right. So the percent error in this case is just a little bit under 2%. A little bit under 2% error. That is extremely accurate. So like I said before, if those numbers had been, if the percent error for 193 students was super high, I would say that the coin probably is not accurately balanced. And the theoretical probability should not necessarily be 50-50. But the more students' data that we look at, you can see the closer we get to that theoretical probability. All right, Bobcats, I just wanted to take some time to look over that data and give you some experience with theoretical versus experimental probability. Theoretical probability is the probability that you get in theory. In theory, a coin flip should be 50-50. Experimental probability is the probability that you get when you actually run the experiment. And then percent error is how close to the theoretical probability the experimental probability actually is. So I hope I didn't bore you to death, but this is a great look at some data, and we're going to be looking at some more experimental probability in the coming days. All right, Bobcats, have a wonderful day. See you next time.